Okay, some people were freaked out on the last problem set when the arc length or the radian didn't have a pi in it. And not every arc length and radian has a pi. If you think about it, the circumference here, if you think about it as a distance, as a person walking, there's infinitely many points. Some of those points are multiples of pi. If you walk exactly half the circle, you walk a pi. But lots and lots of points in between exist. Every number you can think of that's between 0 and 3.14 exists there along your way to pi. So you definitely can have lots of distances that you could travel that wouldn't be a multiple of pi. For example, this problem right here. This distance is 9 centimeters, which happens to not be a multiple of pi. We can still find the radian, however, because the radian is just the relationship between the arc length and the radius. So when we find that ratio, 9 centimeters divided by 3 centimeters, we just get a radian measure of 3. Now, why does this make sense that the radian measure would be 3? Well, the radian measure of this point right here, 180 degrees, is pi. Now, we've been talking about it constantly always as pi because that's the exact value. But if we needed to, we could think about it as being about 3.14. We can see here so that if this person walked, they'd walk about 3.14 centimeters when they got to pi. Since they walked a little bit less than that, they walked about 3 centimeters, or they walked exactly 3 centimeters, but you can see that that's a little bit less than making it all the way to the pi. If we were going to convert 3 radians to degrees, that would mean that the degree measure would be something a little bit less than 180 degrees. And it is possible, just because this doesn't have a pi in it, doesn't mean that it can't be converted to degrees. Now, there was lots of different conversation about how to convert things to degrees. Let's go to the next slide. So we had 3 radians, which we are, and good problem solving skills saying, is just a little bit less than 180 degrees. So we know that it's less than 180 degrees, but only by a tiny little bit. So how do we convert radians to degrees? Well, we know that the arc length formula works when it is 1. So you got 2 pi times the radius, but again, if the radius is 1, because we're in degrees, is theta over 360 degrees. And that should equal our measure of 3. So again, I got this from the arc length formula, but I don't need to worry about the radius because we're talking about radians, so we can assume that the radius measure was 1. So if you're solving this equation right here, you multiply both sides by 306, both sides by 360, and I get 1080 equals 2 pi theta. And then I could divide both sides by 2 pi. This is not at all the only way to convert radians to degrees. There's lots of other ways. This is just the way that I chose to do it in this video. So that's 540 divided by pi, which would actually have to be the exact value. Anything else you're going to give is an estimate. But so that we can see that it's a little less than 180, let's actually do 540 divided by pi. And that's going to be approximately 171.89, which is a little bit less than 180 like we thought. So as we can see, this is, it's degrees. If this is a little bit of an estimate, which is what happens when we don't use multiples of pi. So they're not impossible. It's just that the the radians to degrees doesn't go back and forth as nicely when it's not a multiple of pi, but it's not at all impossible.